Are you confused about whether to use tf.nn.dropout or tf.layers.dropout in TensorFlow? You're not alone. Today, we're diving into this common question and clearing up the confusion once and for all. I totally get it. Many developers find themselves scratching their heads over these two functions. It can be frustrating when you're trying to optimize your neural networks and can't decide which dropout method to use. Let's look at the specific question that sparked this discussion. One user asked, what's the difference between tf.n.dropout and tf.layers.dropout? They noticed that many NIST CNN examples use tf.nn.dropout with a parameter called keepProb, but they were unsure how this compares to tf.layers.dropout, especially regarding the rate parameter. So, what's the difference? Both functions are used for dropout regularization, but they have different use cases and parameters. Understanding these differences can help you make the right choice for your model. Stick around, because by the end of this video, you'll not only understand the differences, but also know when to use each one effectively. Trust me, you won't want to miss this. To understand the difference between tf.nn.dropout and tf.layers.dropout, let's start with tf.nn.dropout. This function is primarily used for applying dropout to a tensor during training. The user specifies a keep probability, which determines the fraction of input units to keep. On the other hand, tf.layers.dropout is a higher-level API that simplifies the process. Instead of a keep probability, the user specifies a rate parameter, which indicates the fraction of units to drop. This can be more intuitive for some users. It's important to note that while both functions achieve similar results, the parameters they use are different. The keep probability in tf.nn.dropout is the complement of the rate in tf.layers.dropout. For instance, a rate of 0.5 in tf.layers.dropout corresponds to a keep probability of 0.5 in tf.nn.dropout. Additionally, the user should be aware that tf.layers.dropout automatically handles the training and inference modes. When the user sets training to true, it applies dropout. Otherwise, it passes the inputs through unchanged. In summary, while both tf.nn.dropout and tf.layers.dropout serve the same purpose of regularization through dropout, they differ in their parameterization and ease of use. The user can choose based on their preference and the context of their project. In summary, while both functions serve the same purpose of preventing overfitting, they differ in their parameters and how you specify the dropout rate. This distinction is crucial when you're building and tuning your models. Fun fact, the concept of dropout was introduced in a paper titled Dropout, a simple way to prevent neural networks from overfitting. It's amazing how a simple technique can have such a big impact. Now, let's look at the answers provided by other users. This user clarifies that both tf.nn.dropout and tf.layers.dropout serve the same purpose, but they have different parameters. In tf.nn.dropout, keepProb indicates the probability of keeping each element, while in tf.layers.dropout, the rate parameter specifies the fraction of input units to drop. Specifically, a rate of 0.1 means dropping 10% of the units. They also point out that keepProb can be calculated as 1 minus rate. Additionally, tf.layers.dropout includes a training parameter which is not present in tf.n.dropout. The user advises checking the documentation for detailed differences. Let's take a look at another answer from another user. According to another user, tf.nn.dropout and tf.layers.dropout are identical during training, provided the drop rate and keep rate are consistent. However, they differ during evaluation. While tf.nn.dropout continues to randomly drop units, tf.layers.dropout acts as a transparent layer, dropping nothing. Therefore, in most cases, it's advisable to use tf.layers.dropout. That's the end of that answer. Let's see another perspective. This user clarifies that tf.nn.dropout scales weights by 1 divided by the keep probability during training. In contrast, tf.layers.dropout scales weights by 1 divided by 1 minus the rate. During evaluation, you can set the keep probability to 1, which is the same as setting training to false. Here's a quick tip. When in doubt, refer to the TensorFlow documentation. It's a great resource for understanding the nuances of different functions and their parameters. And there you have it. You now understand the differences between tf.nn.dropout and tf.layers.dropout. Remember, choosing the right function can make a significant difference in your model's performance. If you found this video helpful, please subscribe for more insights and tips.